Hi, I am Pradeep, correspondent of St.xaviers High School, Balanagar. Today I am going to perform an experiment of refraction through glass slab, and for that we require a glass slab, scale, pencil, protractor and few pins, drawing board, A4 size white paper. Fix the A4 size paper on the drawing board with the help of pins. Now keep the glass slabs in the center of the paper. Trace the outline of the glass slab. Remove the glass slab. Name the vertices of rectangle as A, B, C and D. Take a point E on the longer side. With the help of protractor, draw a perpendicular line at a point on the longer side AB of the rectangle. Now draw a line from a point of intersection where side AB of a rectangle and perpendicular meet in such a way it makes an angle of 30 degrees with normal by using protractor. This line is my incident ray falling on the slab, and the angle it makes with normal represents the angle of incidence. Again keep the slab on the paper such that it coincides with the sides of the rectangle ABCD. Fix two identical pins on the line making 30 degrees angle with normal such that they stand vertically with equal height. By looking at the two pins from other side, fix two more pins such that all four pins are in a straight line. Remove the slab and pins. Draw a straight line by joining the dots formed by the pins up to the edge of CD of the rectangle. This line represents emergent ray. Draw a perpendicular line to the line CD where our last line drawn meets the line CD. Measure the angle between emergent ray and normal with the help of protractor. This is called angle of emergence. This angle will be almost equal to the angle of incidence. Join E and F. You can see that the light coming from air and entering glass slab, it bent towards the normal, and going from the glass slab to air, it is bending away from the normal. Extend a line with incident ray. Measure the emergent ray and incident ray are parallel. This is called lateral shift. The distance between these two parallel lines is 1.5 centimeters. Now draw a line from the point of intersection where side AB of a rectangle and perpendicular meet in such a way that it makes 40 degrees. 40 degrees angle with normal by using protractor. This is my incident ray. Angle I is equal to 40 degrees. This line is my incident ray and falling on the slab, and angle it makes with the normal represents the angle of incidence. Again keep the slab on the paper such that it coincides with the sides of the rectangle ABCD. Fix two identical pins on the line making 40-degree angle. Such that they stand vertically with equal height. By looking at the two pins from the other side of the slab, fix two pins in such a way that all pins appear to be along a straight line. 4 pins are in a straight line. Remove slab and pins also. Draw a straight line by joining the dots formed by pins up to the edge of CD of the rectangle. This line represents emergent ray of the light. Draw a perpendicular line with the help of protractor. To the line CD, where our last line drawn meets the line CD. Measure the angle between emergent ray and normal. This is almost equal to 40 degrees. This is almost equal to the angle of incidence. Join EF. You will notice that line coming from here and entering glass slab, it bends towards the normal, and going from the glass slab to the air, it is bending away from the normal. Extend the incident ray. Incident ray and emergent ray are parallel to each other. The distance between these rays is called lateral shift. In this case, lateral shift is 2.1 centimeters. In the first case, angle of incidence is equal to 30 degrees and angle of emergence is 30 degrees. Lateral shift is equal to 1.5 centimeters. 1.5 centimeters. In the second case, angle of incidence is equal to 40 degrees and angle of emergence is equal to 40 degrees. shift is equal to 2.1 centimeters. What we observed is angle of incidence is increased, then the lateral shift also increased.